Hey guys, these are your notes on dropped objects, problem solving. Alright, so we're just going to teach you how to apply the kinematic equations to a dropped object. Here's an example of what we're talking about. Say you drop an object off a bridge into a river. What are the distance, acceleration, time, initial velocity, and final velocity? What do we know about those for this situation? Well, when you look at distance, the rock travels down, right? And everything we're going to call down gets a negative sign, right? That means everything that goes up also gets a positive sign, right? So it's kind of like a coordinate plane. Everything in the bottom, heading down gets a negative. Everything heading up gets a positive. So the rock travels. If it's dropped, it travels down a distance. That's a negative because the distance goes downwards. It's not thrown up in the air. Acceleration. Well, which way does the object accelerate? It accelerates down because gravity speeds it up downwards, so it's also a negative acceleration. And one thing you're going to have to actually memorize is that the acceleration has a specific number. It's negative 9.8 all the time, meters per second squared, when something's heading through the air. The time. Time doesn't have a direction. It doesn't go up and it doesn't go down, so you don't have to worry about the positives and negatives. Time is always a positive number when you plug it in. Alright, initial velocity. When something is dropped, it has an initial velocity of 0. It starts out at rest. And final velocity would be right before it hits the ground, right there. And that would be a negative because it's traveling downwards. Alright, so just refer to your list when you're plugging variables in, and you'll know whether to make it a negative or a positive. So here's your dropped object example problem now. The question is, how tall is that bridge? If you drop a rock from it, and it takes that rock 2.5 seconds to get to the ground. Alright? So the time is 2.5 seconds. It takes the rock 2.5 seconds to fall. We know for all dropped objects, they start out with no initial velocity. And we also always know that their acceleration is a negative 9.8 meters per second squared. So these two, we always know those for dropped objects, just because it's just dropped, and the negative 9.8 because that's gravity's acceleration. So while it's in the air, gravity speeds it up at that rate. So always for dropped objects. Alright, now we're going to look for distance because we want to figure out how tall the bridge is. So we're looking for this distance right here. Now don't be freaked out if it ends up as a negative number when you calculate it, because the distance, the rock does travel down, so you're going to calculate a negative distance. It's okay. So VF is the variable that is not given or asked for, and that's a clue. I'll let you go to your list of kinematic equations and figure out which equation has VF that is not asked for or given in the problem. Alright? Take a second to do that and then restart the video. Alright, so hopefully you saw that the first equation, d equals VIT plus a half AT squared, does not have VF in it at all, which is good because it has everything else we need, the top 4 variables there. And we're going to solve for D. With all dropped objects, no initial velocity. That kind of cancels out that first term, 0 times the time. A half of negative 9.8 for all the dropped objects. That's its negative acceleration. And it takes it 2.5 seconds again to go to the ground. We'll square that 2.5. So this term's gone. half of negative 9.8 will stay, times 2.5 squared. Alright, now this is easy, there's really no algebra to it. You just kind of multiply the half and negative 9.8, get negative 4.9 times 2.5 squared, and then you're going to take out your calculator and finish that up. What's negative 4.9 times 2.5 squared? Gotta sign in. So you could leave it open and do it on your calculator while I'm doing it on mine. There we go. So, like I said, you're going to get a negative distance because it falls down. I got negative 30.625 meters is going to be the unit for distance. So we could just say the bridge is 30 meters tall, basically. Or 30.625 meters tall. That could be our answer. We don't have to include the negative when reporting how tall the bridge is. It's pointless at that point. But one thing, when you do solve these problems with dropped objects, you're going to need to know, if I tell you the bridge is 30 meters tall, you're going to need to plug that in as a negative, alright? Because if you drop something from it, that object goes down. So, even when you plug in distance for a dropped object, it's going to be a negative, alright? If I asked you to find final velocity or plug it in, it's going to be a negative, alright? So refer back to your list of negatives and positives, alright? All the things that go down are negative, everything that goes up is a positive.